Hey guys, I'm Voden and welcome to day 11 of Advent of Code. So 2, 1 and let's start. So day 11, Plutonian Pebbles. The ancient civilization on Pluto was known for its ability to manipulate space-time, and while the historians explored their infinite corridors, you've noticed a strange set of physics-defying stones. At first glance, they seem like normal stones. They're arranged in a perfectly straight line, and each stone has a number engraved on it. The strange part is that every time you blink, the stones change. Sometimes the number engraved on a stone changes, other times a stone might split in two, causing all the other stones to shift over a bit to make room in their perfectly straight line. As you observe them for a while, you find that the stones have a consistent behavior. Every time you blink, the stones each simultaneously change according to the first applicable rule in this list. If the stone is engraved with the number 0, it is replaced by a stone engraved with the number 1. If the stone is engraved with a number that has an even number of digits, it is replaced by 2 stones. The left half of the digits are engraved on the left stone, and the right half of the digits are engraved on the right stone. The new numbers don't keep extra leading zeros. 1000 will become stones 10 and 0. If none of the other rules apply, the stone is replaced by a new stone. The old stone's number multiplied by 224 is engraved on the new stone. No matter how the stones change, that order is preserved, and they stay on their perfectly straight line. How will the numbers evolve if you keep blinking at them? You take a note of the numbers engraved on each stone in the line, your puzzle input. If you have an arrangement of 5 stones engraved with the numbers 0, 1, 10, 99, 999, and you blink once, the stones transforms as follows. The first stone 0 becomes a stone marked 1. The second stone 1 is multiplied by 224 to become 224. The third stone 10 is split into a stone marked 1 followed by a stone marked 0. The fourth stone 99 is split into 2 stones marked 9. The fifth stone 999 is replaced by a stone marked 2,021,976. So after blinking once, your 5 stones will become an arrangement of 7 stones engraved with the numbers 1, 2024, 1099, 2,021,976. Here is a longer example. So initial arrangements, after 1 blink, after 2 blink, 3, 4, 5 blinks, 6 blinks. In this example, after blinking 6 times, you would have 22 stones. After blinking 25 times, you would have 55,312 stones. Consider the arrangement of stones in front of you. How many stones will you have after blinking 25 times? So this time the puzzle input is kind of low. But this will become a very high number. So after 25 times, you will have 22 stones. So we don't count the numbers themselves, we count the stones. Okay, so all the stones are divided by a space. Okay. So with here we get the stones and L stones dot size, that's what we return. So thinking moment, how will we solve this? Give me a moment to think about this. Okay, so I think I got it figured out. First of all, the orders of the stones doesn't really matter. Maybe this will matter more in part 2, but for part 1 this does not really matter too much. So I only see that we should do these kind of things, like this. So first we create a function called blink that we can call multiple times. And if the stone number is 0, we just turn it to 1. And else if, we check the length of the string, because they're still a string, they're not an integer. I'm not going to save them as an int array, because I feel that would not make sense in this situation. Or maybe we should. So we create a function blink. Inside, if the number 0 is 1, turns into 1. Else, we check the length of the string. If the length is higher than 2 or the same, and the percent 2 equals 0, then we split into 2 even parts. Then we check if all values are 0 or not. If they're all 0, then we just turn it into 1, 0. But I think if we keep it as an int array, we don't really need to matter too much about that. And else multiply by 2024, and then we just return the size. So yeah, I'll get coding. Okay, so I wrote my code, but something is going wrong. So I think I'm missing part of the challenge, because when I run this, I get a much higher number than the number that I should have, and I am on test data. So I'm missing one specific element, and I don't 100% know why. We just need to do the same thing here. So str, we need to check the length. So voila, and this will print the exact, like the correct answer, and it does not. Okay, let's put the print statements back. Okay, where is this going wrong? Oh wait, yeah, I already found my mistake. I'm still taking the left side here as well. So right, and this seems to be correct. Yep, this seems to be correct. So let's take our data and let's run this. I should probably have removed all print statements, but it works normally. Okay, that's the right answer. You are 1 gold star close to finding the chief historian, and that within 30 minutes. So let's see how part 2 is. The historians sure are taking a long time. To be fair, the infinite corridors are very large. How many stones would you have after blinking a total of 75 times? Okay, wait, is this just like a very, very simple one? Like, I feel like this is way too easy. So I will have a new record already. Okay, so let's see about this. This will take a lot longer normally. Yeah, it does take a lot longer. But if I can finish in like 1.5 minutes, then I'll have a new record. There should not be any infinite loops. So I have been thinking maybe I should try, like if I have to do so many different calculations, I should probably use threading. I could create a thread pool and send half of the array to different threads. Or like split the array into like 4 parts and then do it. Like for this example, for this code, this will be perfect. Also, let's remove this. I don't need it anymore. And yeah, it's basically just a matter of waiting for Godot to finish. Okay, come on, come on, come on, come on. 10 seconds left. Please work. I want a new record. But I will have a new record anyway. I just wanted to finish within 30 minutes. And I cannot anymore. I can see that my PC is doing something. The memory also keeps going up. I hope that won't become a problem. Normally not. Yeah, in this situation, creating threads that divide the work would have probably been the smartest move. I think that's also why they said are very large. Okay, I think this may be more challenging than I thought. I think at this rate Godot will probably crash or have other issues. It's taking a little bit too long and my memory keeps going up. Like I have 15 gigabytes, well 16. So it should not really be a problem, but I'm slightly starting to worry. Okay, so I had to restart it. I created some extra code tools, run everything into different threads. I hope it's working. I have not actually tested it. It's been running. My threads are doing something. There's some amount of movement going on. Yeah, let's hope this goes a little bit quicker. I can already see the RAM going up by a lot more. Okay, well, I will need to stop this because my swap memory is getting used and my PC is just starting to really become way too slow. So all that time for nothing, I guess. I don't know what I should do. Should I wait a little bit more or should I just cancel it right now? Because right now it's not looking like it will finish anytime soon, I guess. Okay, yeah, no, this is going too far. Okay, let's stop this. Back to the drawing table. Okay, and I finally got the correct answer. So it loads within a second. And if you look at my clock, it's 9 o'clock right now. Basically, my previous code, I kept letting it run in the background because it took hours to finish. Like it was doing something, I could see that. Like every now and then it would say like, one thing got, like one thread got finished. Because this is my code. Basically, I created threads, a mutex. I first created a shortcuts array. Let's already delete that one. Yeah, basically I filled in the array, the dictionary with empty arrays under certain keys for each run. I would start the thread going over every stone and then wait for the thread to finish, but let's delete this because the code apparently did not really work anyway. Then I have my blink optimized, first blink thread. That was the code that was running everything, and the done let me know that it was done. And yeah, here is my code. I don't 100% know what was wrong, but I think one of the things was I started at 0 and I counted up until 75. I changed it to this. So blink ultra optimized. So we just pass in a stone and a run, and basically the cache, that's from an idea from somebody on the Discord server, because I was struggling a little bit with this. I bent over my time of 2 hours, but in total only by like 30 minutes of like actual coding over it. So yeah, the runtime, I was doing other things anyway whilst it was running, so I don't really count that. But yeah, so if we have the cache of like that stone and that run, I used a dictionary for that with vector 2. I thought that was better than my previous solution of creating a shortcut with a specific integer and such. I don't know why I did that. Yeah, then basically if the run is 0, that means that we reach the last iteration of that stone. So then we return just 1 because it's exactly like 1 stone. If stone is 0, then we run the exact same function with 1. So again, like a reiterating, like a repeating function, same like at the last challenge or the previous challenge. Then we check if the length is 2. If it's 2, then we do this. We take the left and the right of the. We first convert the integer to a string and then to an integer again. Then here, and afterwards we add it to the cache and we print the results. And let's see if my answer is actually correct or not. If it's not, then I'm giving up. And it's, oh, I was ready to say then, and it's wrong, I quit. Okay, that's the right answer. You're 1 gold star closer to finding the chief historian. You have completed day 11. This was really more of like an you need to optimize challenge in my opinion. And I thought my second attempt at like the whole multi-threading and such was going somewhere. Apparently not. Anyway, I finished this. A big thanks to all my Ko-fi supporters. Thank you very much for supporting me. And I'll see you guys tomorrow. Bye bye. Yes, I'm sleepy.